So STP, right? We're going to jump into STP real quick. We all love spanning tree, right? So STP, this is the 802. Wow. Yeah, 802.1d spanning tree, the original. And what was its purpose, right? Again, why do we need it?
What
Anyone?
questions? Come on, everyone.
Stop layer 2 loops.
There you go. So some people get that wrong, right? Some people think that it's a different definition, but that's the whole point of spanning tree, right? It's a loop prevention, right? Loop avoidance, stop layer 2 loops from happening. Now, what are the drawbacks? Specifically with like spanning tree protocol 802.1d. Speed, Magnus with speed, slow timers, blocking links, more than one, not all
Sometimes
links
difficult to
utilized.
maintain.
Yeah. Yeah. If we go to the next
so,
level, why blocking some links is a problem? So blocking some links maybe is not a problem, but what is the real drawbacks with this blocking port, having this blocking port?
A convergence.
Like in convergence time.
No, not also this point, but also from business perspective, because as example, you're having like a lot of links, and maybe you have like 10 links, each of them 10 gigs, and you're losing half of your capacity. All 50% of your connection and links are idle. You're not actually utilizing them. So
Yep.
from business perspective, actually you're losing a lot of your assets. You have these assets, you pay for it, but you're not using them. You're just staying idle most of the time. So this is something. This was a really drawback from, in my point of view, from spanning tree. In addition to the normal stuff like the slow convergence and causing some network meltdown if it's configured wrongly and so on. Yeah.
Yeah, I would agree. And there's a lot of people in chat saying the same thing, Mohammed. And I would say it too, right? Like, why would you have redundant links and not use them? Like, why would you not use your links? And spanning tree makes an active standby configuration, meaning that everything's active. It's on one side of the design, and then everything's kind of a failover situation. So now there's ways to mitigate that, which we can get into. You could split it off, right? You could do subsets where one link is active for certain VLANs or certain topology information, and the other link is active for others. And we'll get into some examples of that in a little bit. I think we added a picture on the slide, but I don't know if it's going to come up in the animation first. So there's 3 additional flavors of STP, right, to deal with the slow convergence. So we have per VLAN spanning tree plus, which is PVSTP plus, and then we have rapid per VLAN spanning tree, right? So again, STP 802.1d was really kind of a single instance of spanning tree, okay? And then we have per VLAN spanning tree with every VLAN gets its own instance of spanning tree. And then we deal with the slow convergence of spanning tree with rapid per VLAN spanning tree. So there's additional capabilities and features that mitigate that slow convergence, and we can show those in a minute and show what you have to do. And then we have multiple spanning tree. And MST has those same convergence additional features to make it fast, right? So MST still has the same features, but it also solves another problem that comes with spanning tree. And then I think there's this, there we go. So there's that slow convergence example, right? We got blocking, listening, learning, and forwarding, and you can see the delay, the time frame delay there in that example.
Mm-hmm. Some situation you can stay 30 seconds, other situation 50 seconds till you converge, which is a huge amount. I just thought something came to my mind, Zig, like for us like engineers and also the people who developed spanning tree, maybe Radia Parliament was one of the main authors of spanning tree. You develop something and then you start improving it bit by bit, adding knobs and so on. And then maybe you come with idea outside of the box. So you say, why to have spanning tree and have like layer 2 avoidance? Why not maybe have something like routed access, or have something like trail, or some other people call it IP fabric or fabric path or whatever. So sometimes you have like a good idea, it does the job, and then you discover some drawback. You keep improving it till you find that maybe there's no way to keep it like the best performance, getting out the best performance out of spanning tree. So you come to another idea out of the box and create something completely maybe new for the layer 2 world.
You got it. In chat, someone's mentioning Rep2, resilient Ethernet protocol. which I don't have slides in here on that as well, but that's another option too, right? Again, it's all that layer 2 loop avoidance architecture technologies, right? And for time, I'm going to keep going here. If you have questions, feel free to ask, right? So some design considerations regarding spanning tree. And before I hit next for the animation on this first bullet, I want you all to know that I hate spanning tree. I hate it. Again, like what Mohammed was saying is, you have redundant links, but you're not going to use them. You have a lot of issues where you're spanning, VLANs between locations that you don't need to be spanning VLANs. One broadcast storm across multiple switches, multiple places in the network. So with me saying that I hate it, do not disable spanning tree in a layer 2 network. So if that's what you're using, don't disable it. You're going to create leaps, right? Again, what's the purpose? What's the why? Right? If you have another protocol you're going to leverage besides spanning tree that's going to mitigate loops, then that's great. But if you have spanning tree and that's all you have, don't remove it, right? Don't disable it. Root bridge placement, right? That's a design consideration. So keep that in mind. You can do that on a per VLAN basis, right? So you can identify who's going to be the root bridge for every VLAN you have. Now that gets a little granular, and maybe it gets a little over engineering if you're doing it for every single VLAN and you're making it different devices in your environment. I would recommend you pick 2, a primary root bridge, a backup root bridge, right? Always pick 2 at a minimum, and then alternate which VLANs are going to go where. Almost kind of like in a grouping, if you will. And that's a great question, William, right? So why is the root bridge placement important, right? And we'll get into an example in a little bit with a diagram. I think that will answer that question. So if your question's not answered in that diagram in a few slides, please chime in again and we'll go into detail on that. All right. And then for better convergence, right? Again, the whole point, the original spanning tree protocol was very slow to converge. So the recommendation is to use rapid PVST plus or MST. They deal with the convergence issues, right? And then the lower the root ID, the better it is. That switch will be the root bridge, right? Now keep in mind here, if the lower root ID is lower when you add a new switch, what happens? Does anyone want to give an attempt at that answer there, that question? So the response is don't leave your root bridges to chance, right? Manually configure them. The reason why I say this, you want to design where your root bridges are going to be, and you want to make sure that not a new switch being added doesn't become the root bridge, right? You don't want that switch to become the root bridge and then reconfigure your whole entire spanning domain to go to that one switch. Now keep in mind, spanning tree is going to block ports. It's gonna put a port in a blocking state or a disabled state, and so traffic's not going through that blocked port. So if your root of your spanning tree, your primary root bridge is in the access layer of your layer 2 architecture, let's say, well, now all your traffic's going to be going to that access switch and then eventually going up to the core or the distribution layer. And again, we'll show you in a minute what that looks like with a diagram and a flow of the data. Any questions on this, Mohammed, or anyone else?
There's a couple of questions in the chat. One question from Borak that we are talking about, like, if spanning tree protocol will actually tend to do like layer 2 loop avoidance, and he said that sometimes these loops occur. So he asked why. This may be because of some misconfiguration, or when you have like a broadcast storm and it's like this unknown, and they keep running on the network, and maybe also they can add on that. The second question, I believe also from Kevin, will we need to pay attention to root bridge when using things like HSRP? Yes, this is a good question. The initial answer is yes, and we have like a use case talking about this, right, Zig? I believe it's one of the last slides in our one of the last slides on our discussion. Any other questions, guys, before moving to the next topic?
Okay, so if there's not any questions, I think for Barak's question, I think there's also like a line potential issue, like a UDLD is another solution. But if you have a unidirectional traffic being sent on the physical cable, STP is not going to always catch that. Spanning tree is not always going to catch that loop. And so sometimes you could have a loop coming in where spanning tree doesn't catch it. And so you'd also want to enable UDLD, which is another form of a loop avoidance mechanism, but it's more based on the fiber optic cables or even the Ethernet cable sending a unidirectional signal, right? One way, not bidirectional. So hopefully that helps. There's a couple other use cases there too that might be beneficial, but they're like corner cases. All right, so in the case that you don't use rapid spanning tree, right? Let's assume the hardware doesn't support it. Whatever vendor solution you're going with, there's some improvements to help with convergence, right? So we have uplink fast, fast link, uplink failover used on access switches, right? And this is just to help you reconverge or converge a lot quicker than the normal spanning tree configuration. We have backbone fast, which is fast convergence between devices when STP changes occur. This is usually going to be between your root bridges, right? You want to be able to, when things change, let's propagate those changes quicker than we normally would. Port fast, and hopefully everyone knows what port fast is, but let's change our configuration on our access ports to come up immediately or as quick as possible. And really what that does is that moves it directly into the forwarding state, because the assumption is that there's no switch on the other end of that. There is no possibility of a switch on the end of that. It's just an edge device, a server, a client computer, a device like that. Yeah. All right. Now, STP stability.
If I may add, Zig, for the previous slide, so port fast, you always configure it to your access. So instead of waiting like 30 seconds, when you plug in a PC or something, it will go directly on the forwarding and learning mode. For me, the uplink fast is like, if you have like access switch, you have like the root port, and you have like a blocking port. This also will improve the switch time from when a failure happens to the root bridge link. Backbone fast is mainly for like there's a remote failure. If you have like a ring from 3 or 4 switches connected together, and there's a failure not locally to your switch, but in a remote switch, this also will improve the convergence within your own switch. Maybe we can draw it in the next time, but this is I try to maybe explain the difference between the uplink fast and the backbone fast. Yeah.
No, that's great, Mohammed. We didn't have a diagram for that one. Honestly, I don't know how many people are using non-rapid spanning tree. And so some of these things are inherently resolved with rapid spanning tree. So we didn't create a diagram for that, but we do have a diagram for some of these stability features with spanning tree. So on that note, STP stability, we have BPDU guard, right? So this disables port fast enable ports if they receive a BPDU. I added a T there, BPDU there. So if that access switch receives a BPDU, if you have BPDU enabled on that port, it's going to go ahead and remove port fast, and so that port can function correctly with spanning tree and then block the port if it receives that BPDU. And a BPDU is what spanning tree sends, right? Switches send that data, that packet, and so if you connect a switch to an access port, that's the situation where BPDU guard would help you, right? It would actually come in and say, hey, I received a BPDU. I should not be receiving this on this access port. There's a problem, right? There's something going on. Now, BPDU filter, this is another option, suppresses all BPDUs on ports. So BPDU guard only actually does anything when it receives a BPDU on a port, right? So it has to receive a BPDU, whereas BPDU filter actually does receiving and sending BPDUs. So it kind of like is a demarcation option, which is actually the use case that I've used it before, is a demarcation. If you have different STP environments and you don't want to send or receive BPDUs between them, think of like a provider environment. Maybe you have multiple providers, or maybe you're a customer of a provider, or maybe it's your internet access layer. You can actually enable BPDU filter, and that way you can make sure that you're not going to receive or send BPDUs between your environment and that other person's environment, other organization's environment. Root guard prevents external switches from becoming root. right? So this is going to protect your root bridges. You're going to configure it so you can protect your root bridges, and that way nothing else can become root within your STP topology. And then loop guard prevents an alternative port from becoming the designated port if no BPDUs are received, right? That's going to help your access switches from using a different port if there's no BPDUs receiving that port. And these are usually sometimes questions that people ask, where do I apply these things, right? Where do I actually apply these? And so we have a little topology here on where we apply. And yeah, we have two distribution switches, DSW1 and DSW2. The left one is the primary root bridge for everything. The right one's the secondary root bridge for everything. And then we have one access switch on the bottom, and we have one client just for the time being, right? So for this, if I go through the animation, the first thing I care about is root guard, right? I want to protect my root bridges. So where would I put the root guard? And we'll just throw that out here. We're going to put it on those links that are going from our distribution switches down to the access switches. I hope that makes sense, right? We want to protect our root bridges. All right. And then the next thing I want to do is loop guard. I want to protect us from our looping information. And so I'm going to put that on the links between our distribution switches, our root bridges, but I'm not done, right? That's the first step. And then the second step is I want to put it on my access switches on their side of the uplinks going to the distribution switches. Hopefully that makes sense, right? But this is a good way of identifying where you're going to put these from your configuration standpoint. And that's loop guard. And the next thing is port fast, right? Now this is, again, it's for the edge devices to come up a lot quicker. Mohammed said you can go from 30 seconds to like immediately, right? You really skip the whole STP process and go straight to forwarding state. I'm going to put that on my edge ports, right? Also, BPDU guard is going to be put on our edge ports as well. Because again, we're not going to be receiving BPDUs on those interfaces because they're our access ports. But what if someone plugs a switch in? What if I bring a switch to work and I plug it in? Well, I want to protect that port because port fast literally goes straight to forwarding state. It doesn't even check for BPDUs. But BPDU guard will check, and it will also remove port fast if it receives the BPDU. Hopefully that makes sense. Hopefully this is easy to identify. You can take a screenshot of this if you need it for any reference as well. Mohammed, I'm going to bring it to you. You have any questions? Comments?
No, it's brilliant. No, I agree with you. It was like straightforward. We have a couple of questions here also again from Brock. He's asking like, if we have like a campus network with a couple of switches, all of them are rapid spanning tree except one is still using the legacy STP. In this case, does this switch will affect the convergence of all other switches? This is the first question. Also, he's asking about the same question if it's MST domain with one switch STP.
Yeah, so those are specific, obviously, situations. On the first one, let's see, Rapid STP, and you have one of them that is not, and it's running legacy STP. So Rapid STP has backwards capability with legacy STP, and there's mechanisms in place to mitigate any potential issues within Rapid STP. Now, there's some caveats that you have to make sure are there. I don't remember them off the top of my head. I think it might be that the Rapid spanning tree environment has to have the root bridges. You can't have the legacy STP switch have the root bridge. Mohammed, do you happen to remember that by chance?
Not really. So let's check this point. I don't want to give you the wrong information. I prefer to give you a solid answer, so maybe we can keep this one as one of the questions to address it next time we meet.
Yeah, okay, that's fine. We can add it because, again, we want to do the research and make sure, but I'm pretty sure that's the case. I'll double check that for you, Barak, and I'll let you know. And then the second question you have there about MST. So I know MST for sure needs to be the root bridge. So if you have an MST in multiple instances, if you don't have it as the root bridge and you're trying to do like a common spanning tree migration, it's going to break both spanning tree environments. All right. So definitely need to have the MST environment as your root bridges, and you're going to have to map everything over to that common or that STP environment. But as for the timers, I will get that information for you.
Lastly, there was a comment or note from Samuel. when you enable globally PPDU guard and PPDU filter, only fast port will have those enabled. Yes, good note. Thank you, Samuel, for that.
No, that's great, Samuel. Thank you.
Yeah. If there's no other questions, we can move to the next one. I believe we are almost 15 minutes. We are behind schedule, but yeah, let's proceed. A bit faster, Zig.
Yeah, well, it's just the questions, man. You know, I'm going to keep going. I'm trying to push forward. Yeah. A multiple spanning tree, right? Question: why would we need multiple spanning tree? What's the why? What's the why? What's the reason that this isn't even a thing?
Yeah, and maybe you need to link it to the pair VLAN spanning tree and pair VLAN spanning tree.
Nice, Barak.
Yeah.
I like what Barak said there, right? And again, I'm sorry if I'm pronouncing your name wrong. Big networks, right? And the implication there is you have lots of VLAN, right? So the whole point of multiple spanning tree is to reduce the number of spanning tree instances. Think of every spanning tree instance has to get computed on the switches, so it's resource intensive. And if you have 100 VLANs, it may not be that big of a deal these days. But let's say you have thousands of VLANs. Let's say you have 3,000 VLANs. Every one of those VLANs is going through an SPT process that takes memory and CPU cycles. So MST is a solution to merge those spanning tree instances into one common kind of instance, as long as you have the path you want to take, right? So all those VLANs are going to take that same path throughout the architecture. So if you want to kind of mitigate that and put them all into one instance, one calculation, that's great. It reduces the CPU, the memory, but then it's all going to take that one traffic path throughout the architecture. And that's what I said here. Combine like traffic flows into a single MST instance. You know, and now STP is ran once for the entire MST instance, even if it includes 1,000 VLANs or 3,000 VLANs, et cetera. And then why would this be used over other SP options, which we've already kind of mentioned? I led with that question, right? I'm moving on, Mohammed. So if you want me to stop, go ahead. Yeah.
No, I agree with you, but I just want to maybe make it like an example, especially for pair VLAN spanning trees. All spanning trees was like one instance for all VLAN, and so that wasn't scalable. So I mean, let me tell you how the things happen. So spanning tree was putting everything on all the VLANs, treat them on the same spanning tree. I mean, one instance, so one port will be blocked, the other port will be forwarding. So people try to be smart. They have like pair VLAN spanning tree, and they start having, like, for example, dividing the VLAN, a couple of VLANs on the right switch and the other on the left. So, like, you know, the normal load sharing option. And then this was consuming the switches resources a lot. So they said, let's, because we have, like, example, 1,000 VLAN, we can put 500 of them, they will be treated the same. The other 500 will be on another NST instance. So you just have like 2 copies of spanning tree instead of 1,000 copies of spanning tree running on your switch. So it was like a way of, as Zig mentioned, it's a way like saving and improving like the spanning tree and switch resources.
Yeah, exactly. And so I'm going to mention this real quick. We're going to run out of time, right? We started a little late. We had some audio issues. We're going to hit the hour mark. If you guys are cool with it, we can keep going, right? Like, I'm free and we can keep going and hit all the slides. If anyone isn't of it, want to keep going, we can always do a second session as well. So maybe put your comments in chat. Let us know what you want us to do. We'll push until at least 6 o'clock my time, a.m. And then if you want us to keep going, we can. And obviously we're recording it. We'll send out the recording